Welcome everyone at my talk about navigating the CI/CD landscape in the Kubernetes era. So I'm going to be talking today, of course, about Kubernetes, right? What else? And with the introduction of Kubernetes, everything from deployment to monitoring to scaling is more standardized and inherently easier to automate. And this presented us with the opportunity, the possibility to achieve a more effective and comprehensive CI/CD experience, where we can incorporate the practice of infrastructure as code and take advantage of an entire ecosystem of tools to improve and fully automate our application deployment strategies. Right, so in this session, we will tour the landscape of new and existing Kubernetes-centric tooling, including Tekton, Kustomize, ArgoCD, and more. And we'll also explore how GitOps can be leveraged for CI/CD. Now, before I move on, let me just quickly introduce myself. I'm Andreas, and I have actually been an employee of Ordina in the past. I've started my career here, and honestly, I have to say that I couldn't think of any better place to start your career than Ordina. I've learned so much, met with so many interesting people, and been on so many interesting projects. And after 10 years, I eventually moved on to Pivotal, which was a Silicon Valley scale-up of about 6,000 people, and the home of the Spring framework. So the Spring team was part of Pivotal, as well as Cloud Foundry. If you've ever worked with Heroku, it's very similar to Cloud Foundry. It's still to this day a superior developer experience than Kubernetes. But of course, Kubernetes these days is becoming the de facto standard for any cloud deployments, right? After a couple of years, we got acquired by VMware, where I've spent some time as well, until recently, when I moved over to a fintech startup called Core Financial. At Core Financial, we are truly a globally distributed team, where leadership is spread around the world, in the US, the UK, and the EU. And we have really a mission that we're trying to accomplish here. And our mission is to avoid another financial crisis by mapping out risk in the financial markets. Right? And when you want to map out risk, you have to look at different financial instruments, different products that are being traded by financial institutions. Products like, for instance, CDOs. And that's, of course, this is all pretty difficult terminology. It's all very specific jargon to the trading industry. And if you've ever seen this movie called The Big Short, you might remember that Selena Gomez was there to explain some of this stuff to you. And I thought, why not introduce a little clip, a little section of that movie to introduce the reason, one of the financial products that were the cause of the 2008 crash. Let's have a look.
So here's how a synthetic CDO works. Let's say I bet 10 million on a blackjack hand.
10 million because this hand is meant to represent a single mortgage bond. Okay, Selena has a pretty good hand here, showing 18, dealer showing 7. That's a really good hand for Selena. Good odds. In fact, her chances of winning this hand are 87%.
So my odds are good. I'm on a winning streak. Everybody in this place wants to get in on the action. How could I lose, right?
Now, this is a classic error. In basketball, it's called the hot hand fallacy. The player makes a bunch of shots in a row. People are sure they're going to make the next one. People think whatever's happening now is going to continue to happen into the future. During the real estate boom, markets were going up, and people thought they would never go down.
So people who are watching and think that I won't lose will make a side bet. Now, this is the first synthetic CDO.
I love Selena Gomez. I bet you 50 million she wins, and I'll give you 3-to-1 odds.
3-to-1 odds? Okay, I'll take that bet. Now, somebody else is going to want to make a bet on the outcome of their bet.
50 million she wins.
That will lead to synthetic CDO number 2.
Hey, I bet you 200 million that lady in the glasses wins that bet.
She probably will win, so I want a great payoff.
How about 21?
Deal.
And this will go on with more and more synthetic CDOs.
And we can transform an original $10 million investment into billions of dollars.
Right. So what we are building is basically a platform to give insights, real-time insights based on regulation, to make these products like these synthetic CDOs transparent to the market and regulators, right? So the crowd that's behind Selena Gomez, right? That crowd basically we want to make sure that we know how many people are part of that crowd. Cool. So let's then take a look at how we do this, right? Well, we have to architect for scale. Scale because actually we are talking about 12 petabytes per year that we have to store and actually make available. So you have to be fully cloud native, right? You have to be on Amazon Web Services for this kind of scale. And so we are fully hosted there. And we use technologies such as EKS and MSK. And so EKS being our managed Kubernetes installation, and MSK being the managed Kafka clusters. There is someone not muted, I think, because I hear a lot of typing and a lot of clicking. Anyway, I'll continue. So the architecture that we're using for Kafka is basically based on event sourcing and stream processing. So you might be familiar with Kafka in a pub/sub semantic, and so pub/sub itself is definitely the right way to use Kafka, but you can actually store your messages for longer than just for the consumers to have the opportunity to consume, right? Now, what if you would keep that retention time not just to 7 days, which is default, but actually to more than 7 days? Why not just to infinity, right? Then you would actually have the same as a database. And Kafka in itself, like the essence of Kafka, is also a database, right? And the append-only nature of it is just semantic addition on top of a database. So Kafka being an append-only log brings the idea of a transaction log, which is actually in every database, has a place in every database. It brings that to the fore, and it makes it that as part of the protocol, right? So for us, it's really easy to store all of our data inside of Kafka and keep the historical records there forever, right? So a lot of data, right? And so we need to have our application also robust enough to be able to keep track of that data, because this is 12 petabytes per year, which is a lot of data. But it is even more so important that we keep all of that data inside of our platform. We have 12 petabytes where we cannot lose a single byte, right? As opposed to, for instance, IoT, where you can have sensor data. If you would lose some of that data, it wouldn't be such a big deal. But for us, we have to make sure that we are robust and we are resilient, and we cannot lose anything, right? So that brings a couple of challenges. And so our pipelines have to make sure that security, of course, is shift left. We're talking about the most prized data of financial institutions, right? The most secret data, the financial transactions that they are sending to us, right? So we need to make sure this is very secure. So we need to have a pipeline that has shift left security. We also need to make sure that we have that we have all the checks in place, that it's functionally going to work exactly how we need. Oh, 1 second, Ryan. I think somebody's take a look. I think someone's not muted. Is that possible? All right, anyway, I'm just going to continue. But I think maybe we should mute everyone. I don't know. Anyway, yeah, let's move on. All right, so that means we need a decent path to production, right? As you can see here, this is a typical path to production that most people are familiar with. So on the left side, to make a code change, you can do that in a feature branch. You can make a pull request. You can have some reviews on that. That's all cool. Then you have your code committed. You can do some tests on that in your build pipeline. Then you can package it up. Maybe define some declared state. Depends on how you do that, or deployment, of course. Eventually deploy it to an environment, which could be a VM or anything. Then on that environment, you can do some more tests. You can promote to other environments, and eventually perhaps deploy into production, right? Where you can do a strategic rollout if you want to, and you can test. So strategic rollout, for instance, could be blue-green, could be canary, could be any type of strategy while you're deploying. So you're testing it. You can do rollbacks, automated rollbacks perhaps. But if everything goes well, your stuff gets deployed in production, and you have to maintain it there. Right, so with the introduction of Kubernetes, things actually changed a little bit here. So of course, our environments became Kubernetes, which gives you infrastructure as code, self-healing, so the reconciliation loop, and extensible API, so the ability to extend the platform with custom CRDs, for instance, custom resource definitions. That's very, very powerful stuff. Now, that gives us a lot of possibilities, a lot of opportunities in the rest of our pipeline. Right, because now we have this infrastructure of code as code and all of these plugins and all these ways to automate things. We can now look at different ways of filling in these boxes. Right? And of course, I'm from a time where we used ClearCase in the past. God forbid, ClearCase it's brings back memories, probably nightmares as well. And then we had CSVVS, we had SVN, right? Eventually we had Git, and everybody kind of settled on Git because it's not just version control, but it also gives you fancy things like pull requests and merge requests, right? So that was very useful for us to build on top of Git, right? So Git itself doesn't really offer that, but there's so many distributions that use Git underneath that do offer that. So that was very, very useful. It's also a distributed version control system, which was also a kind of a breakthrough. So as you can see, many of these boxes now become just basically Git itself. But that's not enough. We have more work to do. And so build the package, for instance, packaging. We used to build jars. Used to build jars within ears, right? And then that package, that huge ball, was then transformed into an application server. This was just basically copied to an FTP server or something, or to some kind of VM, and then that was deployed onto an application server. Now, we figured out that wasn't the best way of doing it. If we have all this automation, right, then we can just as well have our own web server inside of a jar, right? We don't need the application server itself anymore. So the move towards self-contained jars, brought about, for instance, Spring Boot, right? Really useful Spring Boot. You can just do Java minus jar, and then your jar, and basically your application starts. That's really, really good to start with. But then we still had our operating system. We had our JVM. We had, when you're using Java, of course, we had all the other dependencies that we had to manage, right, on our VM. That was not very useful either. So we moved to containers, right? Containers like Docker, and that was good for a while, and people are still using that a lot. And I wouldn't say any other way. Because we are using Kubernetes here, of course, you need to use something like Docker, like OCI compliant images. But is the Docker file the right way to do this? Maybe not, right? Let's talk about this in a moment as well, how we can improve that. But Docker files, they have some downsides, right? So Buildbacks help resolve some of these downsides. They give you an easy way to build images with autonomous rebuilds, and it allows you to patch the OS layer at scale. So let's talk about that in a second, because it's really interesting, I think. So then, of course, we also can add something like Argo for GitOps. It doesn't have to be Argo, it can be anything else as well, like Flux or any other reconciliation tool that uses Git as a source. That gives you basically a continuous operation semantic. So an idea of continuously operating what's in production or what's on your environment by looking at what your state is, what your declared state is in Git, right? So that's GitOps. We talk about that as well. And then, you need to kind of tie it together with a workflow. You need some kind of workflow engine. And since we're on Kubernetes, this could be Tekton. Tekton is kind of the default standard these days for workflow engines on top of Kubernetes. But we'll see what the pros and cons are there as well, because it's not that straightforward. So now we've got our pipeline, we've got the boxes filled in. There's, of course, alternatives, which I'll go over for each of these technologies, right? But let's start with the Buildbacks, right? So what are cloud native Buildbacks? Cloud native Buildbacks is basically a sandbox project. I think it's even graduated now. Initiated by Pivotal and Heroku in 2018. The concept came from Buildbacks themselves, from Heroku, and then also from Cloud Foundry. And now they're a cloud native Buildbacks project on their own, based on Kubernetes, right? So that's pretty useful. Well, it's some of the platforms are based on Kubernetes, I have to say, to be completely exact correctly. And then, of course, what this does is it allows you to orchestrate builds, right? So you don't have to write your builds, your Docker file yourself. And then, of course, there's also the idea of platforms and Buildbacks. We'll talk about that in the next slide. But eventually, what you get is this OCI image. It's also a unified standard to enable an ecosystem of both platforms and Buildbacks. So just for the next slide. And it optimizes for fast rebuilds, minimal data transfer, and efficient OS rebasing. And what that means is in 2 slides from now. So the first thing to talk about would be these platforms and Buildbacks, right? So on the one hand, on the left side, you've got platforms. So there's a bunch of different implementations that you can use for platforms. And one is the PAC CLI. It's just a simple CLI you can use. And you can basically instruct PAC to inspect your code base, right? Whatever it might be. It could be a JavaScript app, could be just static files, it could be Python, it could be Go, it could be Java, it could be Groovy, it could be anything, right? It will inspect it, it will detect different languages, and it will then take some of the Buildbacks on the right, and you can select which Buildback bundle you want to use. And you have Paketo, you've got Heroku, you've got Google Cloud that comes with their own Buildbacks as well, Tanzu as well from VMware. And you can use those to then build the layers that are necessary for your Docker image or your OCI image, right? So you don't have to do that yourself anymore. You don't have to define a file anymore. It just completely does that by introspecting your code. And it does it in a way smarter way as well. Because if you do it yourself, remember writing your first Docker file, it might be, you write a from line at the top, and then, okay, what do I base myself on? Which base image do I use? Right? If you're using a specific tag, you're already doing a good job. But there's many people who use just a floating target there, right? Just a floating image. And then the whole image itself is no longer deterministic, because if you build it again, it might be completely different now because the base image changed. Right? But then locking down into a specific tag there, the base image, well, that has downsides as well, because I've gone through a lot of different companies the last couple of years, and I've done a lot of kube control get pods, right? And what I've noticed is that in most big enterprises, a lot of companies like this, they have containers running for multiple months, right? And that's almost unthinkable before we had Docker, right? Before we had Kubernetes, that those were actually VMs that were patched on a daily basis. Right? We had an operations team that was patching these VMs, right? That was patching the operating system and the application server and the JVM. All of that was being patched to make sure there's no vulnerabilities. But what we're doing now is apparently we're just targeting a certain Ubuntu version or whatever, and we're just leaving it like that, right? That's very, very dangerous, right? Because now, that's kind of a trade-off that you get when you start to say, you build it, you run it. Developers now are responsible for this, but developers don't really care about all that patching, right? So, if you can kind of automate that stuff, that would be really great. And here, these Buildbacks, they kind of do some of that stuff for you. So they will detect which OS that you need, and they will attach a run image. And that run image is exactly that base image that you're depending on. And that run image, we'll see in the next slide, can be switched out for a new one really easily. But before I go there, on the left side, you can see some more platforms like KPAC. Spring Boot, Tekton, and so forth. And so Spring Boot also has a plugin, a Maven plugin, which allows you to say build image, and it just does the same thing, right? It also just uses all these buildbacks, and it will do all that introspection. It even, for Java, there's the JVM buildback, which will introspect all your code and see how much memory you will have to consume. And it will actually put something inside of your container that will do it on startup. On startup, it will check how much memory do I need to assign for this specific container run at this time, which is quite amazing, right? You wouldn't ever be able to put that in a Docker file yourself, right? So of course, there's also security implications of a Docker file. You can expose too much in terms of privileges, but also in terms of attack surface. If you don't clean up your builds information or builds data that you've pulled in for building, if you don't have multi-stage Docker files, then of course you can run into all kind of security vulnerabilities there, right? So then the KPAC part, that gives you this automatic rebasing functionality. And the rebasing functionality basically says you have a Docker registry or a container registry full of images, right? And by the looks of it, half of them are now vulnerable because there's a vulnerability that came out yesterday. Okay, what do we do? In normal scenario, we have to contact all of those teams, and it could be hundreds of teams, right? In an enterprise, maybe even thousands of teams. And we have to ask all of them, can you do a new build? But first, update your Docker file, use the latest OS base image, right? Please do it as soon as possible. And then just upload all that stuff, right? Probably going to take weeks, if not months, to get that done, right? So that's not really useful. This here, however, it can go into the registry and it can create new images because KPAC was responsible for creating it. It knows how to recreate it, and now it just swaps out the run image with a new version. And this actually happens in sub-second performance. Can you imagine sub-second performance for all of your images? Because it is just a pointer that is changing, right? So it's super fast. And it can do that for all the images inside of your registry. That is just insane how much gain you have here compared to the weeks or months that you have by doing it manually, right? And that is, if you would not use that in your enterprise, that would be pretty foolish, if you would ask me. So now you have an image, let's say, right? You've used Cloud Native Buildbacks, amazing, right? You got an image. Now you have to still deploy this stuff. How do we do that? Well, somebody would probably say Helm. Let's use Helm, right? Helm is the package manager for Kubernetes. And it also offers a lot of configuration customization possibilities. That's true, yeah. It does a lot of stuff. But that's also a little bit of the downside. It does a bit too much, perhaps, right? So, you can have your manifests in there, all your Kubernetes manifests, all the deployment stuff that you need defined as declarative state inside of your Helm chart. And then you have some volume files for different environments where you specify how these parameters inside of these manifests that Helm adds in there have to be filled in, right? That's amazing. What really is great about this is that for off-the-shelf software, like for instance, I need a Prometheus, right? This is really, really good. Because, Prometheus, you can say, I need that version, and I just want to deploy it in my cluster right now. And that works really, really well. The thing is, not all applications work the same way in terms of versioning, right? So if you look at Prometheus, that's being released as something that people can install themselves. But if I would say, give me the version of Gmail, for instance, right? Gmail, what's the version? You probably not know, right? Unless you're a Google expert, a Google engineer, right? So you don't Google engineer, right? So you don't know, and you probably don't care, right? You don't care what version this is. It just has to work. Same way for an application that you're basically using in your own organization that's being hosted by another product team. So a product team might be deploying like a microservice, for instance, and you have to use an API. You surely care about the version of the API, but you don't care about the version of the application, right? Like which deployment this is, I don't care, right? I just want this to work. I just want to be online right now, right? So with SaaS applications, and those are all SaaS applications, right? You don't really care about the version. So having a semantic version being imposed on top of your regular jar version, for instance, in Java, that's just awkward, right? It just extra versioning on top of that. And Helm kind of forces you to use semantic versioning. And semantic versioning for SaaS applications doesn't make any sense anyway, because when do you have a breaking change? Who knows, right? What does that constitute, a breaking change for a SaaS application? It's the APIs that can be breaking, but it's not the application cannot break because nobody's importing that as a library anywhere, right? So that's kind of weird. It's kind of awkward that Helm kind of goes that way for all kind of applications. It's just inherent to how Helm works. So it's not that great for continuous delivery or continuous deployment. And frankly, if you look at these manifests, right, they use Golang templating, which is the mustache templates, right? The mustache templates allow you to do if then else, right? The conditional logic in there. But that implies that you have indentation to make sense of that, because you're going to have nested ifs, right? But the thing is, you add it on top of the YAML, and YAML has forced and fixed and strict indentation. Right? So you add it on top of that, you can't really make sense of what ifs you're actually in right now, right? And then all of the other parameters in there, it really gets tricky to understand what's going on. So it's not that nice. It's not very clear, and it's not declarative by default. So you say Helm install, that's an imperative command, right? Of course you can make it declarative if you want, but it's just the default nature of the tool it's kind of imperative. So if not Helm, what else, right? Now, why not Kustomize? If it's just configuration management that you need to do, and frankly, most of the cases it's just configuration management, then you can use Kustomize. Kustomize does one thing, the configuration management, and it does it well. It cleanly separates static resources, which are in manifests, which are fixed, and resource changes, which are overlays. So anything that's like a delta on top of the base manifests, that's defined in overlays. Right? And so, for instance, if you're deploying to another environment, you need to change some environment variables. That's very likely to happen, right? There's some connection to a database or whatever, right? It's different for each environment. So then you would only change those specific environment variables inside of the overlay and have the entire manifest completely as is, fixed in the other, as a static file. And no mustache templates in there, right? You can actually deploy that separately as well if you'd like. And you just have a customized file which links both together. So this is really nice because it's as simple, right? Simple, but still powerful, because the transformers that you can use, they really give you a lot of possibilities there as well. But the base concept is just much more easy. It's also part of kube control, and it's a bit controversial how that got into kube control, but it's there now, and you can just as well use it. It allows you to use config maps in its lifecycle as well. It tracks it in its lifecycle, which is very nice. Other tools sometimes omit config maps being tracked as a lifecycle. So, that's nice. The downside here is that not every part of the manifest file can be changed, can be selected in an overlay, right? So, most cases it's fine, but sometimes you'll hit these corner cases and you might say, okay, in this case, I'll have to do something manual. So cool. So that's basically how you can get your stuff deployed, right? You can define your files in Kustomize or in Helm if you really want to, right? And then you deploy that with the kube control apply. You could do that, or you could use GitOps. And now, what does that mean, GitOps? Right? GitOps is actually just a set of 4 principles defined by Weaveworks. And the first principle is that the entire system should be described declaratively. Now, declaratively, what does that really mean? I've been talking about imperative and declarative, but it might not be clear to everyone. So, this little example here about how to get to the library explains it pretty well, I think. So I could tell you, if you ask me, how do I get to the library? I could tell you, well, you go from the city center where you're right now, turn onto Route 4 North, and then at the traffic circle, take the next exit. First light, turn right, first available right turn, then traffic circle, start left lane, third exit, library is the first building on that road. Good luck with that. And then you'd say, okay, great, I'll get going. Chances are you'll get there. Chances are you won't get there, right? Because maybe, something happens along the road. Maybe there's an obstruction somewhere, roadworks or anything. Then you will be lost because you'll have no way to kind of reconcile. You have no way to change your plan, because I've just explicitly given you instructions of how to get there. I could also just have told you the library is this address, and then if you have a GPS, of course, you could just get there from wherever you were, because on the left side, if you start at number 3, you would have no idea which first light this is, right? Because are you on the right street? Who knows? So on the left side, you see there's a smart instructor. I've told you exactly how to get there, but the engine is not that smart, right? The engine is just executing commands, instructions, and you must begin at the starting point. Whenever something deviates from the plan, you're kind of screwed. And on the right side, I'm not really involved as an instructor. I just gave you an address, and you are so smart that you can get there using something like a GPS system. And then you can recover easily from any starting point because, well, frankly, your address is still going to be the same. The desired state is still the same. So if you look at how what it means in Kubernetes, kube control offers you a bunch of imperative commands and one declarative command. And so the imperative ones are like create, run, expose, edit, batch, label, scale, annotate. And these are great for creating YAMLs. It's troubleshooting, learning, experimentation, or getting your CCAD certification, right? You don't want to type all that YAML yourself. You just want to generate it using these commands. But you wouldn't be using all that stuff to go to production. No, you would use kube control apply. Why? Because there's these things called controllers in Kubernetes, and those are GPS systems, right? They get you to that desired state. So you can just as well use the GPS and say, well, kube apply this address for me, right? Just get me to this state and just do whatever you need to do to get there. That's great for creating reproducible deployments. So now that we know a little bit what declarative means, we need the entire system described as declarative. And where do we need to describe this? In Git. Everything needs to be described and stored in Git because there it is. We've got role-based authentication controls or authorization controls. We've got rollbacks, which are trivialized that way. You can just do a reverse commit, done, right? You've got auditing, logging, everything you need in that system. Awesome. But now, do I need to put this in one repository? Do I need to put it in multiple repositories? Do I need to have a repository for my code and one for my configuration? And do I need to have multiple environments for each configuration, separate environments? Well, that's a bit of a tricky question. There's pros and cons to each approach, of course. And if you put them in separate configuration repos, then you have the benefit of RBAC. You got separation of access, cleaner audit logs, and so forth. And basically, your pipeline becomes more modular, right? Because now you've got these separate repos. So every step of the pipeline is now decoupled with this elbow joints, which is the repo commits, right? If whether that's a good or bad thing, that's up to you, of course. We'll talk about that in a second as well, what that means. And then you can have triggers and can trigger actions based on different life cycles. And of course, it makes sense if you have coupled deployments. I hope you don't have too many of those, but if you do, then these coupled deployments, if they're in different repositories, where are you going to put the configuration to deploy all that stuff together? Where are you going to put it? In which of these repositories? In which of these applications? Well, no problem. Just put it in a separate configuration repository. Problem solved. So there are some pros and cons to both approaches here. I don't know if, most people would say go for the configuration repo separately because of the RBAC, right? So then what else is important for GitOps? So the third principle is that approved changes, so once they are merged, for instance, with a pull request, they can be automatically applied to the system. So automatically, they are just kube control, apply, boom, done, right? So for that, you might need something else that monitors your Git repository and deploys it automatically. And then, of course, you need some software agents as well to ensure correctness and to alert you in the versions. So if there's any drifts on the server, on the Kubernetes cluster going on, someone deleted the deployments, let's say, well, then in that case, there might be some tool that helps you to reconcile, right? So that's all good and dandy. So what do we use for that? Well, maybe something like GitOps tooling like Argo or Flux, right? And of course, Git is Git, and then the first one is, of course, Kubernetes. So those tools, they give you, there's different kind of tools, and some of them are better at some things and other ones are better at other things. So Argo, for instance, this one, the little octopus, it's kind of focused on an application. So it has the concept of application. It even has a custom resource definition for that, which is, of course, a set of Kubernetes resources. And so it really focuses on that application deployment. It also provides you a UI with advanced enterprise authentication capabilities. Flux, on the other hand, that one doesn't really have that application context because it's more geared towards it's more geared towards I should have turned off my notifications, sorry. For the application, well, for basically bootstrapping the cluster before your applications are being deployed. Let me just close some of this stuff. Yeah, great. So then another interesting feature of Flux is that it can scan image repositories, so like your Docker registry, for new versions and automatically update the cluster, right? That's pretty cool, isn't it? So then you don't need a pipeline anymore, basically. It just goes automatic. And then, it doesn't have a UI like Argo. It does that intentionally. So now, these are a couple of tools that you can use for that. There are basically this reconciliation loop, which uses Git as a source and Kubernetes as the place to deploy and to monitor. But not just one environment. You often need more than one, right? You need the dev environment and then at least a production environment, but maybe some UAT, acceptance environments, some integration environments, some testing environments, some QA environments. You got all kinds of environments. So what happens to your pipeline if you introduce GitOps? And that's something that's not really discussed in a lot of places online. Like you don't find many blog posts about this, right? You don't find many conference talks about this. Right? What do you do in those cases? Well, you have a couple options. Between environments, you need to promote your application, right? And before, we just had one pipeline which deployed to test, and then or to dev, and then if you run some tests after deployment was finished, and then you deploy to UAT, and then you test their acceptance, and then you test there, and then you deploy to production, and you test again, all synchronous. Why? Because, well, the pipeline triggers the deployment. Now, however, GitOps doesn't really allow you to trigger a deployment. No, you make a pull request, right, or a commit somewhere in a separate repo, and then GitOps independently checks that repo and just scans it, and it sees, oh, I got something. An asynchronous check is doing, and it's going to deploy that change into the cluster. Now, your pipeline has no idea when this is going to happen, especially not when there's a pull request waiting, right? So now you've got a pipeline that's stuck, right? Let's take a look how to solve that. Now, this is one way to do it. Now, I've got 4 possibilities. Let's quickly go through it, right? So at number 1 on top, you see that I have a code change committed to my source repository. Now, in this example here, I'm using GitHub Actions, but you can use Tekton or any other workflow engine that you like. Now, here you see that we have a build server, GitHub Actions, running a build and testing. And then, of course, building an image and putting it into the registry on number 2. Now, you've got, after that, you know that the package is built and it's tested correctly. Now you have to deploy it to some environment, right? So we have to promote it to the dev environment. So what we do is we update the dev repository. In this specific example, we have a dev repository, so a configuration repository per environment. For simplicity's sake, I've only got dev and prod, but there could be many of those, of course. So what we see is that we promote to dev, which means you change the image tag in that dev repo, and we do that in a separate branch. We create a PR, and then we have a merge. This merge could be automatic, right, based on some checks that a bot is doing or something, or it can be a manual approval by someone. So once it's merged and it's in the main line, the image tag has changed for this dev repository. So Argo, in this case, or any other GitOps tool, will see that and will say, oh my God, I need to do a deployment here because my source of truth, my declarative state has changed. And I see that my cluster still has the old tag, so I'm going to have to make that deployment happen, right? So it does that. It does the job that Argo is supposed to do. And then once that deployment's finished, it needs to inform the pipeline job that Argo is supposed to do. And then once that deployment's finished, that means there's a webhook call that can happen. Argo can send out a call to some place if it finishes the deployment. Great, let's use that, right? Number 7, as you can see, there's a line going from Argo back to the pipeline saying, test dev now. Right, we want to test dev because we just made a change there and we want to see if it worked, right? So that's dev, that's working fine. Okay, then we promote to production, which means, again, we make a change in the prod repo this time. We change the tag and we create a PR, separate branch, create a PR. And now, of course, we want a manual, or if you're feeling lucky, you might do some kind of continuous deployment. But that merge request gets merged. Okay, then what happens? Okay, again, the same cycle. And ArgoCD picks it up, deploys it, then sends a webhook to the test prod part on the left, which is the blue one, right? And the blue one, as you can see there, that one has then the responsibility to test the deployment that just happened. And if it doesn't work, then we need to roll back, right? So what we need to do then is we need to make a change on the prod repo again. To roll back that change, we need to change the tag there, right? Roll it back and not make a PR this time because it needs to be done automatically, right? Because we want this to be rolled back as soon as possible. We don't need approval for that. And then, that change will happen. Argo will pick it up and it will send a new webhook after it deployed the rollback to test the rollback, of course, because you also need to test that. Benefit of this, on the left side, you see there's one repo for all pipelines. So all pipelines are in the same repo. They're in the source repo. However, there's 3 separate pipelines in the source repo, right? They're not connected. They're not synchronous. They're asynchronous. They're being triggered by Argo. At least the two specific ones for an environment. And important to notice, there's a possibility that there's no notification when the deploy doesn't complete. If Argo did not complete, there will be no webhook call, and therefore, okay, I'm just gonna kill Slack for a second. There we go, solved. So, and therefore, you might get a deployment failure in production, which you have no idea about. Just imagine that. Your pipeline doesn't tell you that. You don't get an email, and hopefully, hopefully, you're gonna have some alerting on there. But if not, well, that's a pretty bad situation. So this is, has pros and cons, right? Let's take a look at another one. So here we've got one repo for all pipelines. Again, the same way as before. We got one pipeline to rule them all, right? Guarantee the pipeline failure when deploy doesn't complete. Why is that? Because, as you can see, there's a little difference here. On the left side, the pipeline now is a synchronous pipeline. There's now arrows between the yellow and the blue, and the green, and the green and the blue. Right? These arrows basically make sure that the next step is automatically being triggered. That helps us from missing any deployments that could have gone wrong, right? And how we can do that is by using the Argo CLI. Argo CLI, we can call it and we can wait for a deployment to finish. The problem is, if you are deploying to production, right? You make a change, you make the image tag changed on number 9 on the right. Right, the image tag has changed. Right, you change the PR, or you create the PR. That PR might be there for a while, right? The PR might be open for a day, maybe weeks, maybe months, who knows? And all the time on the left side, GitHub Actions or whatever workflow engine you're using, that job is running. It's just polling and polling and polling ArgoCD. Is it deployed yet, guys? Come on, deploy. While this PR is just not getting accepted. Right? And worse, if the PR is being declined, this is actually never going to finish. So you're going to have to manually clean up all of your pipelines that can no longer finish. That's also pretty bad. So you see, all of it's because we add GitOps, which creates this asynchronicity in your pipeline. And now the third option here is, well, why don't we just put the GitHub Actions, those specific workflows, why don't we put them inside of the specific configuration repos for the environments? Right, so that we don't have this one big pipeline anymore. We have them separated for each environment. Right? Now, of course, the downside, you have one pipeline per environment that's responsible for deploying all of the applications that are in there, all of the different commits. Right? So it's very difficult now to figure out which commit was done when and which pipeline was run for which commit and what happens, right? It's difficult. However, of course, here you still have the Argo CLI, so you can also know when a failure happens. This is a different approach you can take, but it also makes it a bit more segregated. It's a little bit harder to troubleshoot. And then the fourth possibility here would be where you put everything inside one configuration repo. So this is one repo for dev, prod, UAT, acceptance, everything you want to have in there. And they would trigger their own separate pipelines inside of that repo, right? The problem here is that with one configuration repo, just like we saw with the repository slide, you don't really have RBAC controls over what happens. Sure, in GitHub, for instance, you can say for certain files that get changed, I want a reviewer to be specifically defined. So you could say, well, for production changes, for those files, we will have a separate RBAC, but it's not by default. It's not all of the GitHub or the Git distributions have this. Here as well, you have the separate pipelines here. And yeah, while the benefit is you have only one deployment repo to track, right? So, there's a couple pros and cons here, but as you can see, this is just very complex, right? It's very complex because we added GitOps. And GitOps sounds like an amazing 4 set of principles, and they are amazing. Theoretically, they're pretty cool. But in practice, it's not that nice, right? It's kind of making it more difficult, especially if you have to create your pipelines all manually, if you have to design all this stuff yourself. Now, that brings us to workflow automation. Some of these solutions make your life easier than others, right? But in essence, if you look at what they're doing, conceptually, it's always the same. They're just using different standards, right? So Jenkins is saying pipeline stage step, Concord is saying resource job task, Spinnaker some others, Circle CI, Gitlab CI, Travis, GitHub Actions, all of them, they have different standard namings. So what Tekton did in the Kubernetes names, in the Kubernetes context, they said, well, Tekton is going to be the standard for all the standards, right? And that way, just like the comic, you just have another standard on top of all the other standards. And they said, well, we're going to now say pipeline, task, and step. Okay, great, whatever, right? So what is Tekton really doing? Tekton is just a generic workflow engine. You can use it for CI/CD, sure, and it's really good at CD on Kubernetes, but you can use it for anything workflow related. And so it helps you to standardize pipelines natively to Kubernetes. So the goal of Tekton is to become this underlying mechanism, this engine where other tools build on top to kind of provide a workflow engine semantics underneath their tool. And that's kind of the takeaway here, because Tekton, you can use it yourself, but you have to do many things yourself. You got a lot of flexibility, but with a lot of flexibility, you got a lot of complexity. So things like, for instance, if you want to do caching, if you want to use a cache, well, you have to manage your own persistent volumes, your own persistent volume claims and everything that comes around it. Especially if you have block store, for instance, block storage, you can't really mount that to any running pod at the same time, right? You have to choose. So what do you do with cache that wants to be used across multiple jobs? Very difficult, right? So all this stuff becomes really complex, especially for an engineer, a developer who just wants to write a simple pipeline, right? So Tekton is very complex. I tried this myself, and I got, for a simple application with only 2 environments, I got about 500 lines of code for my pipeline. So yeah, well, maybe we need something on top of that, an abstraction. And that's where Jenkins X comes into play. Jenkins X is basically designed to run and target Kubernetes and builds on top of Tekton, right? It has Tekton underneath, Draft, Prowl, which is basically called Lighthouse on their fork. It has quick starts and buildbacks. It supports promotion flows with on-demand environments, which is nice. It kind of gives you all this GitOps thing out of the box, right? And then it hides the complexity and offers flexibility. The thing is, Jenkins X, it works like an open source community. So you're basically adopting the same approach as, for instance, how Kubernetes manages its approval processes. And everything's a pull request. Everything has to be done at pull request, just like GitOps, right? But the thing is, just like Keith Morris says, pull requests, they add overhead to cope with low trust situations. For instance, to allow people who you don't know to offer contributions to the project. And he also says imposing pull requests on devs in your own team is like making your family go through an airport security checkpoint to enter your home. And that's so true, right? Why don't you just collaborate? Why don't you just put people over the processes and tools that you're trying to create, right? You can just as well sit together with someone, do some pair programming, some mob programming or ensemble programming, and basically get the same results as a pull request, right? 4 eyes principle, right? Peer review, all that kind of stuff. Maybe you can still have a pull request, and after that, if you really wanted to separate a perspective from someone else, perhaps, but you don't no longer need it, right? And Jenkins X kind of forces you to use it for everything. And that's the thing. Conflating open source software, excuse me, the development around that, so all the rituals around that, right? And if you conflate that with private software development, right, in your own team, it's like the original sin of current software development rituals, right? It's not something that we want to aim for, right? The thing is, we are sitting next to each other, we trust each other, we are not working with separate companies, right? So why do we all have these processes on top of it? And Jenkins X kind of imposes that. You've got other tools as well, not just Jenkins X. You got Spinnaker, of course, as well. I've talked about that in different talks before. Very powerful tool. You know, it can do a lot of really advanced deployment strategies. It also has the unique feature of tracking the state of your deployments across all of your clouds, your clusters, your regions, your accounts, your deployment platforms. And it can give you this composite UI, and it can use that information to drive pipelines. Really, really cool. However, very complex to set up, and it's a platform that needs its own team, basically, right? So you need to spend a lot of efforts into maintaining this. Very complex to set up. So it's only something for enterprises, I'd say. I'm just gonna take a drink. All right. Shoot, no water. Okay, anyway, I'll wrap up. So that's, you know, it's some downsides to it as well. And then GitLab CI, you know, it does a lot of stuff, but the most important feature there is auto DevOps. And that basically sets up an entire complete pipeline and necessary integrations for you without you having to write a single line of code, which is pretty cool, right? All of this functionality that we talked about, except maybe GitOps a little bit, it doesn't really implement that too much. But you know, a lot of the building blocks of our pipeline that we saw, basically GitLab does that out of the box, and that's called an opinionated pipeline. And that brings me to my final point: opinionated pipelines. Right? Opinionated pipelines, they avoid you from having to write boilerplate code, which is probably the same for 80% of the projects by abstracting it away, right? Because if you look at most of these microservices these days, they all have the same pipeline structure, right? So why do we always have to repeat ourselves? Why do we have to rewrite, even if we want to create our own library in our own company, our own Jenkins Groovy library or whatever, right? Why do we have to do that ourselves? Why can't there be a product that does all of this for us? And you know, that's what Auto DevOps kind of attempts to do. And in a way, it's conceptually the same as Spring Boot, because Spring Boot also provides an opinionated interpretation of the Spring framework, right? It just puts everything into libraries, and it offers you defaults, and then you can easily override these defaults with properties, right? So that's a similar structure. Same thing for cloud-native buildbacks. It's an opinionated way of building and containerizing your application, and you can override defaults as well. Spinnaker, an opinionated advanced deployment strategy platform. Jenkins X uses quick starts with draft to provide you an opinionated way of bootstrapping your pipeline. It's a little bit more like Spring Boot. What was it again? Spring Brew instead of Spring Boot, but still, it's a lot of things that it does out of the box. And you know, GitLab's Auto DevOps, that's an opinionated, full-featured, end-to-end pipeline, including support for cloud-native buildbacks. So if you look at the pipeline that we started out with, all these different building blocks here, wouldn't it be nice to have this opinionated pipeline kind of grouping everything together? And I really hope that the industry is moving more and more towards this opinionated pipelines in the future, so that we don't really have to deal with all of these complexities of all these building blocks. Because frankly, Kubernetes is already complex enough as it is, right? We don't need to add all of this complexity on top of that. And with that, I think I'm well over time. Apologies for that. But I'd like to thank you for your attention. And hopefully we'll get to talk as well after in the room or something, where I'll just walk around or something. You can always approach me. So thanks a lot.